Hi, this video is in preparation for Tuesday's class. Just a little review of velocity and its applications when it comes to integration. Okay, so back to our little car. We have our little car here, and our little car can travel, in this case, we're only going to allow our car to travel in left and right direction. We're going to think about this as being straight left and right. Okay. So, in calculus, velocity, and this is a physics concept too, velocity has a sign because velocity is a measure of speed and direction. If you've taken physics, you've probably talked about that. So, a lot of times in calculus, when velocity is positive, that's an indication that the particle is moving either to the right or up. And we talked about this when we talked about acceleration. And when velocity is negative, that means the particle is either moving left or down. So let's think about this. So let's think about this little car. This little car could move to the right, positive velocity, or it could move to the left, negative velocity. Now let's look what's happening. The car is moving to the right, positive velocity. Oh wait, look at the car. And then it's negative velocity. What does it do? What happens when the velocity changes from positive to negative? Well, when the velocity is equal to 0, the car stops. Now let me go back and didn't want to do that. Let me go back, put my car here, and I'm going to put some little tick marks on. And we'll make this equal to 5, and then we'll make it negative 5. So let's imagine what's happening to the car. The car travels to the right 5, and then it stops, and then I'm going to have the car go back to, let's say, negative 4. So what did the car do? The car went to the right for 5 units, and then it went back for 4 units. Oh no, it didn't go back 4 units. Silly me. How far did it go back? It went back 9 units. So if we look at what the net distance was, the net distance was it ended up traveling a negative 4 units. It started at 0, ended up at about negative 4. But the total distance was 9 plus 5, which was 14 units. I'm going to go through another example and just to make sure this makes sense. So here's that car again. I'm going to have the car go, let's see, over 3 units. Then I'm going to have it go back to negative 5. So the car went here to 3 units, so it went here 3 units, and that when it went back to negative 5. So if we were to think about the net distance, think about where it started and where it ended. It started at 0 and ended at negative 5, so its net distance was negative 5, but its total distance was 3 and 5, which was 8 units. It's like what it says on the speedometer. If I go 3 miles forward and 5 miles in a different direction, the speedometer will say 8 miles. This leads us to the 2 formulas for today. The net distance traveled is always the integral from start to finish of velocity, v of t, dt, where the total distance is equal to a to b absolute value of v of t dt, which means net distance is a simple problem. Total distance, we have to worry about where it's positive and where it's negative. So if we have to worry about where it's positive and where it's negative, we're going to have to do a little quick drawing of the velocity and understand where the velocity is negative, and we're going to have to do two integrals. We're going to have to integrate it separately if we don't have a calculator. If you have a calculator, math, if you press the math button and then press the number button, NUM, absolute value symbols will come up. But without a calculator, what you're going to do is do a quick little sketch of the graph, and you're going to integrate it in pieces. The first piece, and then add the second piece, just taking the absolute value of the second piece. Sometimes net distance is also called displacement. Okay? So just be aware of those differences in words. All right, so make sure you bring these notes to class tomorrow, and it will help as we work through some problems. Have a good night, and I will see you then. Bye-bye.